Hi everyone, I'm Rui, and in this video I'm going to use the DataMiner SDMN solution to book and orchestrate a service to transport compressed SD video between two different locations without having to deal with any manual workflows or operational activities. To book a service, we need to navigate to the Connect tab. In here you'll find the simplest way to book and orchestrate a service. These pages represent the different types of transport available to us on this demo. Both H.264 and JPEG access are compressed SD flows, so we're going to select one. You can assign a default name, which is composed by source port, destination port, and a trailing timestamp. Alternatively, you can override that and assign a custom name to the service. You can set a start time. It's set to start immediately by default, but you can set a specific date time too, as well as the duration of the service before it ends. Finally, select a source port, a destination port, and now we're ready to book a service designed to transport compressed JPEG access SD video from a source in New York to a destination in LA. To do this, just click Connect. DataMiner will automatically orchestrate the service by spinning up the required application on the fly. We'll calculate the shortest path and applying the flow throughout the network, as well as booking all the necessary stuff, computing the resources on the chassis, application licenses, multicast addresses, network bandwidth, and so on. The service will be visible on the overview page along with all your other running services, if any, and will be eligible for the penalty box when it runs into issues. The service will also be included in the surveyor tree under the appropriate view structure. On the Services tab, we have a deeper view on the individual service. This is the visual overview. We can see general information on the top: service state, remaining duration, uptime. If this booking was made from a job, you'd see customer and contract information here. There's also an alarm count by severity. This is the flow diagram from source all the way to destination. Each block contains additional stats about ingress and egress bit rates, multicast addresses, service class, video format, and compression. If we expand the block, we can find even more detailed information on the encoder application. You can also expand the ports themselves, revealing the multicast table where we can see the details on the multicast group in use for our video broadcast, properly identified with a label referring to the service name. The same applies to the other blocks along the flow, where you have relevant information next to them, as well as the ability to expand each device or application for even more details. If I expand the network block, you'll see a nice representation of the chain of network devices through which the flow is passing, along with stats on each of them. The ad hoc table down here would list all the resources that you added to the service on the fly. To do this, you can click on the plus sign on either location. There are additional pages to this visual overview. The North-South page displays additional information regarding the New York encoder and the LA decoder applications and their hardware deployment that is not visible from the East-West view. You can have immediate stats on each computer blade and chassis where they're running, which you can also expand to find more details on. With the DataMiner SDMN solution, monitoring your orchestrated services has never been more intuitive. Now, say I stop the encoder. Alarms will be generated because we're monitoring the products and applications in your service, and as a result, the flow diagram will highlight these issues. The encoder is straight out critical, while other nodes in the network are reporting unexpectedly low bit rates. And the video thumbnails shows us no signals downstream of the encoder. This service will now be visible in the penalty box on account of not running normally. With the penalty box, you're able to focus your attention on where it's really necessary. So let's start up the encoder again and cause an issue somewhere else in the network. When I expand the network block, I can navigate to one of the spines involved in the transport and attempt to cause a problem there instead. For example, I can simply disconnect the cable. As we can see from the network flow diagram, the spine is now critical, and nodes downstream are in major severity due to not receiving the expected bitrate traffic. This is of course bubbled up all the way to the service overview when it is clear that there is a problem in the network. The decoder in LA is also in alarm, and the video thumbnails in LA have no signal as opposed to the ones in New York. And this is how you can use the SDMN app to book, quickly orchestrate, and comprehensively monitor a compressed SD transport service. So keep an eye out for other SDMN videos or related material on our OpenDojo platform. I hope you enjoyed this video, and I will see you on the next one.